My name is John Wiemels. I'm a student at the University of Georgia in the Intro to Geospatial Information Sciences class. This is my final project where I will be discussing structure from motion and how it could potentially help to rebuild the Notre Dame Cathedral. Structure from motion is something we learned about in class, where you can take advanced photogrammetry techniques and apply that to still images created either individually as stills or from video images. And from that, you can use multiple overlapping images to create a dense point cloud that matches certain sets of data. This point data contains both visual as well as positional data that can be used to build and bundle images together to create a series of overlapping images. Then these images can then be geometrically corrected and spatially tied to each other. This is usually accomplished using drone footage or some other type of high-resolution video camera to ensure the highest quality imagery with high amounts of spatial and temporal redundancy. This is an image that I gained online, and it basically shows, at least in a visual forms, the fundamental concept of structure from motion. We're using the individual images as they are portrayed as X1J or X2J, so that you can go from the point at which the image was taken past the image and actually gain positional and visual information about the item that is going to be turned into a three-dimensional object via structure from motion, which is portrayed as what would be the object as XJ. This is an image that was taken from a still of a structure from motion image that we used in class. Here's another image from it. From here, you can actually see that this is a point cloud, as it is demonstrated by the small black dots that are present in the image. These images can then be used to recreate a three-dimensional representation of an object or an area. The accuracy of the structure from motion can be further enhanced by adding in known locational data from which further positional calculations can be attained. The structure in motion is used in multiple fields, from geospatial information sciences to archaeology. It could also potentially be used with the creation of a highly accurate model of the interior of Notre Dame Cathedral and how it once looked. This could have advantages in its rebuilding efforts. Cornell University and other industry and academic partners have created advanced techniques to use structure from motion to document multiple historic sites. They have also created an advanced bundling program that uses crowdsourced images that were not specifically taken in stereo pairs. They are completely independent of each other to create structure from motion data. Tourist images of multiple historic sites have been used as the targets and the use cases in these efforts, and this advanced bundler program has been used successfully multiple times. This is an image taken from Cornell University's site, where they are showing the individual pictures as they were taken around Rome, and they were used to rebuild an image of the Colosseum that is shown in the shot. And from the small areas there, you can see where the multiple images were taken from. This is another image taken from structure from motion data of a cathedral that was used from crowdsourced imagery. On the 15th of April, 2019, a fire broke out at the Notre Dame Cathedral in Paris, as we all know. This fire completely destroyed the roof and heavily damaged the interior of this building. The Notre Dame Cathedral was originally constructed in the 12th century, and it is one of the most culturally significant landmarks in France, if not all of Europe. Reconstruction efforts have been promised by the French government, and to date, nearly $1 billion has been donated for those reconstruction efforts. But there are certain technical issues that are going to hamper the rebuilding efforts of the Notre Dame Cathedral. There's little information known about an accurate blueprint of the interior or exterior of the cathedral. Other data does exist that will help with the reconstruction, such as LiDAR and other high-definition images that have been taken using multiple forms of video, as well as a compression algorithm that was used to create Notre Dame Cathedral as part of a video game backdrop. However, we need to bear in mind that Notre Dame Cathedral is one of the most photographed sites in the world. The massive amount of individual imagery that exists of the inside of Notre Dame, a data call could be issued and have full resolution copies of these crowdsourced images provided to a team. That imagery could be run through the advanced bundling technology used by Cornell to create an individual point cloud and imagery of the interior of Notre Dame. The accuracy of this data can be enhanced beyond what can normally be achieved in a standard structure from motion video or recreation, since there is a huge amount of data and there is already existing LiDAR data that can be used as the initial framework for the structure from motion data to be tied. Once the structure from motion data starts being created, it can then actually be rerun against itself to repeatedly gain more and more accuracy. This can be used, as mentioned before, to recreate the interior of Notre Dame Cathedral as it once was and is portrayed in these images before the fire. Thank you for this. I would like to pay special consideration to Cornell University, for I used much of their research in the creation of the crowdsourced structure from motion information.